Hi there. So what I hope to do in this video is explaining exponential expressions. Now, an exponential expression is an expression that consists of a base and an exponent. So we can say an exponential expression is divided into an exponent and a base. Now, for an exponent is the power to which a number or a symbol or expression is raised. Let's say, for example, when you have b raised to the power of 3. Our 3 here is the exponent. Now, for the base, a base is a number raised to the power of the exponent. So, using our example, b raised to the power of 3, our b here is our base. Now, going into exponents, there is what we call exponentiation. Exponentiation is a mathematical operation that represents repeated multiplication. So, for example, we have b raised to the power of n. Now, the exponent n represents the number of times b, which is the base, will multiply itself. Now, let's take an example when we have b raised to the power of 4. It's simply saying b multiplied by b multiplied by b. That is b multiplying itself 4 times. So, b raised to the power of the 4th power simply represents b multiplying itself 4 times. There's a little thing we have to note, that some exponents has their own unique pronunciation. Let's take, for example, b raised to the power of 2 is read as b squared, or b raised to the power of 3 can be read as b cubed. So, with this being said, you can say that exponents are used in many fields like biology, chemistry, physics, and even economics and computer science. Now, since we have understood the basic idea of an exponent, let's practice using positive integer exponents. Now, the first example we are taking is 2 raised to the power of 3. So, as you can see, we have our base as 2 and our exponent as 3. So, just as we said before, this is equals to 2 multiplied by 2 multiplied by 2, and this is going to give us 8. So this is practically 2 multiplying itself 3 times. Now, another example, we have 3 raised to the power of 5. So this is practically 3 multiplying itself 5 times. So we have 3 multiplied by 3 multiplied by 3 multiplied by 3 multiplied by 3. So this is going to give us 243. That is 243. Now, there is something we have to note in exponents. It's kind of a rule in exponents. When we have an exponent raised to the power of 1, it's going to give us that number raised to the power of 1. So let's take, for example, when you have b raised to the power of 1, it's going to give us back our base, which is b. Or when you have 2 raised to the power of 1, it's still going to return our 2. Or when you have 3 raised to the power of 1, it's still going to return our 3. Now, another rule in exponents is when you have any non-zero number raised to an exponent 0, is going to give us 1. So let's take, for example, you have b raised to the power of 0 is going to result to 1, or 2 raised to the power of 0 is going to give us 1, or even 4 raised to the power of 0 is equals to 1. So what this rule is kind of saying is any number which is not 0 raised to the power of 0 is going to give us 1. Now, the other rules in exponent, like the product rule, the quotient rule, the power to power rule, and the product rule. So we're going to go through this one by one. Now, first of all, the product rule. This simply says when you have b raised to the power of m plus n, it is equals to b raised to the power of m multiplied by b raised to the power of n. Now, let's take, for example, when you have b raised to the power of 2 plus 2. So, this rule is saying that b raised to the power of 2 plus 2 is equals to b raised to the power of 2 multiplied by b raised to the power of 2. Now, another example is 4 raised to the power of 3 plus 5. So, this rule is saying 4 raised to the power of 3 plus 5 is equals to 4 raised to the power of 3 multiplied by 4 raised to the power of 5. Now, let's put this in context. So, we have another example. When you have 2 raised to the power of 2 plus 3, it is equals to 2 raised to the power of 2 multiplied by 2 raised to the power of 3. Now, to further explain this, as you can see on our left hand side, we have 2 raised to the power of 2 plus 3. So 2 raised to the power of 2 plus 3 is equals to 2 raised to the power of 5. Then on the left hand side, this is quite the same. As you can see, it's just saying 2 multiplied by 2, then multiply by 2 multiply by 2 multiply by 2. That is 2 raised to the power of 2 multiplied by 2 raised to the power of 3. That is when you multiply 2 by itself 2 times, then multiply by 2 by itself 3 times. As you can see, all result to 2 raised to the power of 5. So when you multiply through, you still get the same answer. So this is practically what this product rule is trying to say. Now let's go into even a kind of more complex example when you have 2 raised to the power of x multiplied by 2 raised to the power of 2x. Now as you can see, according to the rule, this is equals to 2 raised to the power of x plus 2x. Now another example, when you have 4 raised to the power of x multiplied by 2 raised to the power of x. Now this is kind of tricky because according to our rule, our base has to be equal. So what do we do? As you can see, 4 can be written as 2 raised to the power of 2. So we're going to write our 4 as 2 raised to the power of 2. So this expression will give us 2 raised to the power of 2x multiplied by 2 raised to the power of x. So this is equals to 2 raised to the power of 2x plus x. Now another rule is the quotient rule. This says when you have x raised to the power of m all over x raised to the power of n, it is equals to x raised to the power of m minus n, provided our x is not equals to 0. Now example is when you have 2 raised to the power of 4 all over 2 raised to the power of 2. So this is equals to 2 raised to the power of 4 minus 2. Now when you put this in context, on the left hand side, you see this practically 2 multiplying itself 4 times all over 2 multiplying itself 2 times. So this is just 2 multiplied by 2 multiplied by 2 all over 2 multiplied by 2. And as you can see, the 2 here can cancel 2 here, and 2 here can cancel 2 here, and we'll be left with 2 multiplied by 2, which is just 2 raised to the power of 2. Now when you go back to this, our 2 raised to the power of 4 minus 2, it's still going to give us 2 raised to the power of 2. So this is practically what this rule is talking about. Now the next rule we are talking about is our power to power rule. Now before we move over to power rule, let's solve other examples on our quotient rule. So when you have 27 raised to the power of 2x all over 3 raised to the power of 4x. Now this is kind of complicated, but it's also simple. So what is the first thing we are going to do? We're going to try making our base equal. That is, our 27 and 3, we are trying to make them equal. So what do we do? 27 is still equals to 3 raised to the power of 3. So we're going to write our expression. So this is going to give us 3 raised to the power of 3 all raised to the power of 2x all over 3 raised to the power of 4x. Now in order to continue this expression, we are going to use a particular rule we are going to use in the future, which is power to power rule. Now the 3 here is going to multiply our 2x using the power to power rule. So we'll be left with 3 raised to the power of 6x all over 3 raised to the power of 4x. Now finally, applying our quotient rule, this is equals to 3 raised to the power of 6x minus 4x. So this is going to give us 3 raised to the power of 2x. Now finally, let's go to our power to power rule. We have just solved an example using power to power rule, but let's just use this officially. So our power to power rule says when you have brackets x raised to the power of m all raised to the power of n, it is still equals to x raised to the power of m multiplied by n. So let's take for example when you have bracket 2 raised to the power of 2 bracket close all raised to the power of 4, it is still equals to 2 raised to the power of 2 multiplied by 4. So this is equals to 2 multiplied by 4 is going to give us 8. So this is equals to 2 raised to the power of 8. Now another example is when you have 4 raised to the power of 2x multiplied by 2 raised to the power of 5x. Now as you can see, our 4 here, this is practically the importance of the power to power rule, trying to equal your bases. Our 4 here can be written as 2 raised to the power of 2. So we're going to write our expression as 2 raised to the power of 2 raised to the power of 2x. So multiply by 2 raised to the power of 5x. So when we multiply our 2 with our 2x, which is our exponent, is going to give us 4x. So finally our expression is 2 raised to the power of 4x multiplied by 2 raised to the power of 5x. So this is equals to 2 raised to the power of 4x plus 5x, which is equals to 2 raised to the power of 9x. Now, the last rule we are going to look at is the product rule. This rule practically says when you have x, y in a bracket all raised to the power of m, it is still equals to x raised to the power of m multiplied by y raised to the power of m. So this is where I'm going to draw the curtain on the laws of exponents. And finally, before you go, let's try solving this question, and I would like to see your answers in the comment section. Now, this question is going to require you using all the rules I've talked about and everything about exponents. So it says when you have 27 raised to the power of 2x all over 3 raised to the power of 4x multiplied by 4 raised to the power of x. So try solving this expression, and I would like to see your answers in the comment section. Thanks for watching. Bye.